Hey guys, it's Nancy, and we're going to talk about how to use long division, everyone's favorite, to divide polynomials, so to divide one polynomial by another. You probably remember doing long division back in elementary school and thought you were done with it, and now it's come back to haunt you in high school. So let's look at a simple example first. Okay, so you've been given a rational expression that is one polynomial divided by another polynomial, and now you need to use long division. So the first thing you need to do is rewrite this rational expression in the old division form that you're used to from elementary school. So the top polynomial goes underneath the division sign, and the bottom polynomial, or the divisor, goes to the left. So this still means x squared plus 3x plus 5 divided by x plus 1. Okay, so the first step is to look for the highest power of x on this side and the highest power of x on this side, and find how many times does this x go into that x squared, and that's x times, since x times x gives you x squared. So we put that x up here on top and in line with the 3x term. So that's where it belongs. The next step is to multiply this x by each of these terms and place what you get directly underneath this polynomial. So in this case, we have x times x, which gives us x squared, and we have x times 1, which gives us plus x. Then we want to subtract this line from the first line. So we have x squared plus 3x minus x squared minus x. So we get below 0, nothing here, and we have 3x minus an x, so we actually have 2x down below. Now, if you think back to elementary school when you first did long division, at this point, we carry down, we bring down this number, the 5. So we bring down the next term to this line. So now we ask, how many times does this x go into this 2x? And that's 2 times. So we write 2 here up top, in line with the other number, the other constant. Now let's repeat that first step of multiplying that number, that term, by the whole divisor and writing it below. So in this case, we have 2 times x and 2 times 1, so plus 2. And again, as before, we're going to subtract that line from the line above, and we get nothing here, 2x minus 2x. And here we have 5 minus 2, so 3. Now as a final step, you do need to still ask yourself, does my divisor x plus 1 go into 3 any more times? And the answer is no, because x plus 1 is a larger polynomial than 3. So you're done, and this is your remainder. So in your class, most likely you're going to want to write the answer as x plus 2 with a remainder of 3, and typically you put the remainder over the divisor. So in the bottom we have x plus 1. So that 3 was your remainder, and you always place it in the end over your divisor, x plus 1. So your final answer is x plus 2 plus 3 over x plus 1. Okay, so that was fun. That was a simpler, more straightforward version of the long division with polynomial problem. Now let's look at a harder one. Okay, so we're going to rewrite this again in the other division form. And notice that in this case, in that top polynomial, there is a term missing. There is no x term, 2x, 1x. So we actually will need to leave a placeholder for it. So let's rewrite this. We have 6x cubed, like normal, plus 10x squared. Now, in this place where there's a gap, where there's no x term, we need to write 0x here in the dividend as a placeholder. That's really important that you put that 0x there if there's a gap. And then plus 8. And then our divisor on the bottom, 2x squared plus 1. Same thing, we'll write 2x squared. Notice there's no x term, so we put 0x plus 1. Okay, so now that we've rewritten this problem in the normal division form, let's carry out the same steps as before. So look at this highest power of x on the left side and the highest power of x underneath. And we want to know how many times does that term, 2x squared, go into this term, 6x cubed. So how many times does 2x squared go into 6x cubed? The answer is 3x, because 3x times 2x squared would give us back 6x cubed. So the 3x we place up here on top. Make sure you place it right above the other x term, in line with the other x term. Now, do you remember the step from before? We're going to multiply that term, 3x, by each of these in the divisor and write the expression we get underneath. So, in this case, we have 3x times 2x squared, which gives us 6x cubed, 3x times 0x, which just gives us 0x squared, 3x times 1, which just gives us 3x. We're going to subtract, so draw your line, we're going to subtract that whole second line. It's important to draw those parentheses and put the overall minus so that you get the signs right. So down below, when we use the subtraction, we'll have nothing here. 6x cubed minus 6x cubed is 0. 10x squared minus 0x squared leaves us with still 10x squared. 0x minus 3x is minus 3x. Now remember your long division steps. At the end of this, we want to carry down this number, carry down one more term. So we have a plus 8 at the end. Now, final step in the process, how many times does this biggest term in the divisor, 2x squared, go into this term, 10x squared? And the answer is 5, because 5 times 2x squared is 10x squared. So 5 we place up here, right above the other constant, 8. Now, multiplication step. So we're repeating the steps at this point. 5 times 2x squared is 10x squared. 5 times 0x, 0x. 0 times anything is 0. 5 times 1 is 5. Final subtraction. Draw your parentheses, draw your subtraction line. Down below we have nothing here, 10x squared minus 10x squared. Negative 3x minus 0x is negative 3x. 8 minus 5 is plus 3. So now ask yourself, does 2x squared in the divisor go into negative 3x any more times? And the answer is no. You're done because this term is larger than that term and you can't fit it inside it anymore. So you're done, and this part down here, what's left, this whole thing, is your remainder. So your remainder can be an expression in terms of x. So let's write your final answer. Remember, it's this polynomial, 3x plus 5, and it's your remainder over your divisor. So we have plus remainder over your divisor, which we can just write as 2x squared plus 1. So that is your final answer after the long division. Whew. Okay, so what trips people up in these long division problems is two things. One, they forget to write that 0 placeholder, which is very important. So if you see a gap in the polynomial, so there's no x squared term, there's no x term, there's no number, constant, you must put a 0 term there underneath the division symbol. It's very important. The other thing that trips people up is the sign when they subtract the whole second line. So you don't want to miss points or make a mistake just because of some silly sign error. So make sure you write that negative and parentheses around the second line, because that negative distributes and applies to every term inside the parentheses. So I'm sure that was super fun doing long division. It's okay, you don't have to like math, but you can like my video, so please click like below.